Okay, a lot of folks have always said, "I'll believe it when I see it." And their wait might finally be over because after years of hints from Elon Musk, rumors and wild speculation, the Tesla flying car has finally appeared in Texas. And not only is it real, but the engineering on this thing is breaking every existing rule. With a price tag of just $6,789, and vertical takeoff and landing capabilities straight out of a sci-fi movie, a top speed of 155 mph, and a design that looks like it's from 2030, this is no longer a blueprint or a prototype locked in Elon Musk's secret lab. This is a real working flying car that anyone can place an order for by the end of this year, according to Elon Musk's latest confirmation. Without any further delay right now, let's take a look inside and see what it's all about. One thing I can guarantee is that this product demonstration will be unforgettable. Unforgettable. You know, for over a century, humanity has constantly dreamed of the flying car, a vehicle that could lift us off the ground, soar above congested roads, and touch the sky. I mean, you can essentially buy one and get two. Now the dream of billions is no longer science fiction, as Elon Musk has officially unveiled the prototype of his first flying car, the Tesla flying car. And the company has maximized the engineering breakthroughs poured into this product, as it is fundamentally far more complex than a Model 3 or a Model Y. But while you'd have to shell out at least $36,000 for a Model 3, you only need to spend nearly $700,000 for the Tesla flying car. Yeah, you heard that right. What has stunned the global tech and media world isn't just its ability to fly. The price tag of the Tesla flying car is only $6,789. Cheap to the point of being unbelievable. It's cheaper than an old Honda Civic and even less than the price of a high-end gaming computer. Initially, we thought this was a typo, a sensational marketing stunt. However, Tesla quickly confirmed this price is real. According to Elon Musk, achieving this was possible thanks to three pillars of technology and manufacturing: minimalist design, ultra-lightweight materials, and groundbreaking battery technology, all inherited from Tesla and SpaceX. From the first glance, the Tesla flying car looks like an aircraft straight out of a sci-fi movie. Yet it also has the silhouette of a roadster race car. The entire cockpit is covered by a 360-degree transparent canopy, allowing passengers a panoramic view of the sky, the ground, and the vast vista ahead. Unlike conventional vehicles, the flying car's chassis will be constructed from a composite material combining carbon fiber and titanium. This makes the vehicle both light and rigid, ensuring it can withstand the powerful aerodynamic loads during takeoff and landing. Noted. The advanced aerodynamic design allows the body to automatically adjust its angle of inclination during flight, reducing air resistance and optimizing energy usage. Inside is the characteristic minimalist space of Tesla. Just one large touchscreen controlling the entire system, from takeoff, navigation, and climate control to entertainment. There are no traditional dashboards, buttons, or switches. Everything is contained within a clean, smart, and almost intuitive interface. The highlight of the Tesla flying car lies in its smart folding wing mechanism and retractable tail. In driving mode, the entire wing system is neatly tucked away into two side compartments, giving the body a seamless look, much like a sporty coupe. However, with just a command from the center screen, the wings slide out via electric motors, extending the wingspan up to 12 feet. This transformation process is expected to take only 60 seconds. However, the Tesla only has two sole seats. These are ultra-lightweight, ergonomically designed carbon fiber seats, offering comfort even when flying through turbulence. The generous legroom makes the entire driving and flying process comfortable for both seating positions. Tesla also offers two-door options: traditional opening doors to reduce cost, or gull-wing doors similar to the Model X, creating a sense of luxury and convenience when landing in tight spaces. The demonstration model featured the gull-wing doors, and indeed, it gave viewers the feeling of watching a scene from Blade Runner. Both the wings and the tail are made of aluminum alloy coated with carbon fiber containing auxiliary control surfaces inside to ensure stability during flight. This structure allows the vehicle not only to fly at low altitudes in urban areas, but also to maintain a longer flight range high up in the air. The biggest difference between the Tesla flying car and every currently existing flying vehicle lies at its core: the all-electric powertrain instead of the traditional internal combustion engine. This is a bold move, one that opens up countless opportunities, but also brings with it no shortage of challenges. By choosing the path of complete electrification, Tesla is not only affirming its commitment to sustainable energy, but also continuing to sharply reduce the environmental impact of transportation, perfectly aligning with the philosophy that made their previous electric car lines successful. And as you can see, this shift brings with it a multitude of clear benefits: reduced emissions, lower noise pollution, and drastically cut operating costs. Things that traditional aerial vehicles struggle immensely to achieve. Furthermore, Tesla is already the king of batteries, with a massive and constantly optimized battery technology reservoir. Instead of relying on combustion fuel, they can fully leverage this strength to create a flying car that is more environmentally friendly, quieter, more efficient, and most importantly, significantly cheaper. Tesla revealed earlier this year that they would be using the latest generation 460/80 battery system for the flying car before their eventual shift to solid-state batteries. Currently, the 46 and 80 cells are already renowned for their high energy density, lighter weight, and faster charging capability. These new 40-60-80 cells boast an energy density of up to 350 watt-hours per kg, which means that for the same weight, the battery pack can hold significantly more energy than before. Thanks to this, Tesla can equip the flying car with enough power to operate without having to affix a massive, bulky, and heavy giant battery pack underneath the floor. Another noteworthy point is that the cost of the 460/80 battery is estimated to be about 40% lower than current lithium battery lines. The documentation does not specify the final battery capacity, but it is highly likely to fall in the range of 150 to 200 kilowatt-hours. Tesla has been testing the first flying car prototype in Texas, and results show that in electric vehicle mode, it can travel up to 350 miles. In flight mode, it demonstrated the ability to fly for 2 continuous hours before landing with a top speed of 155 miles. The powertrain system consists of 3 electric motors. 2 motors are placed at the rear to transmit power to the wheels when driving on the road, while the central motor powers the electric fan located beneath the car's body, generating lift when flying. This design allows the vehicle to achieve vertical takeoff and landing and maintain stable flight. The Tesla flying car does not use exposed propellers. Instead, it is equipped with a ducted electric jet propulsion system inspired by SpaceX's rocket technology. These high-voltage electric fans can generate a powerful air thrust, enabling the vehicle to perform vertical takeoff and landing smoothly and precisely. Tesla calls this the Falcon landing tech, the vertical landing technology that has helped the Falcon rockets return safely. As the vehicle takes flight, the central controlling AI takes over the entire journey, calculating safe paths, monitoring weather in real time, and automatically avoiding obstacles. Users simply need to enter their destination. The system handles the rest. Of course, you can still switch to manual mode if you wish to fly the vehicle yourself, provided you meet the basic training requirements. With a top speed of 155 mph, the Tesla flying car is faster than most sports cars today, and it can fly from city to city in just a few dozen minutes. A full charge allows the vehicle to fly for 2 hours, which is equivalent to about 310 miles, more than enough for most daily commutes. Thanks to Tesla's rapid charging technology, you can go from 10% to 80% battery charge in just 30 minutes. Flying in the sky is no simple matter, and Tesla understands this better than anyone. Therefore, they have equipped their flying car with a series of multi-layered safety systems that operate almost independently but coordinate intelligently. First is the backup battery system, which ensures a stable power supply even in the event of an unexpected failure. Next is the automatic emergency landing mode. If the system detects a serious problem, the car will self-calculate the trajectory and bring you safely down to the ground. In the worst-case scenario, the full-body parachute system can be activated, helping the vehicle descend slowly and minimize impact. Going further, 360-degree radar and LiDAR sensors constantly scan the surrounding environment, detecting obstacles, birds, or other vehicles to automatically avoid collisions. And what surprises many is its noise level. It is only about 65 dB, equivalent to a normal conversation. In other words, you can take off from your backyard without your neighbors complaining. All of these technologies combined make the Tesla flying car one of the safest and most advanced personal vehicles ever created. Not just for flying, but for flying with true peace of mind. To bring the price of the Tesla flying car down to just $607.89, Tesla did not follow the aviation industry's conventional path. Instead, they redesigned the entire flying car concept from the ground up, much like they did with electric cars. First and foremost, Tesla adopted the less is more philosophy. Every superfluous detail was eliminated. Instead of hundreds of complex mechanical components found in traditional aircraft, the body is single-piece cast using the Giga press, which both reduces weight and shortens assembly time. The entire production process is carried out in the same Gigafactory, where Tesla integrates frame casting, battery installation, and electric motor calibration on an assembly line that is almost entirely automated by robots. This strategy of co-locating everything helps the company drastically cut labor, transportation, and internal logistics costs. Furthermore, Tesla leveraged the optimized battery and electric motor platforms from the Model 3 and Model Y lines rather than developing entirely new ones. This saved them significant research and production costs. Materials were also reselected. Recycled aluminum, carbon fiber, and composites are used instead of expensive aerospace alloys, making the vehicle light, durable, and easy to mold with the Giga press. Alongside this, Tesla developed a central electronic architecture, a single controller capable of managing the entire flight system, eliminating the hundreds of complex electronic components required by traditional aircraft. Finally, Tesla capitalized on its global supply chain scale. Components like the 40-60-80 battery cells, electric motors, and control software are standardized and mass-produced, leading to a sharp reduction in cost per unit. All of these innovations combined turn the $6,789 price tag into something that sounds like a joke, but is actually real. Developing a flying car is not simply about bolting on wings to an electric Tesla. It is a true revolution in engineering and design thinking where every previously existing limit must be rewritten. The moment the vehicle leaves the ground, all the physics rules we are familiar with change: lift, drag, stability, weight distribution, everything must be calculated at a microscopic level. And Tesla understands clearly that for a vehicle to fly safely, they must adhere to the world's most stringent aviation standards, which are many times stricter than those in the automotive industry. Much like the development journey of full self-driving technology, the Tesla flying car will have to navigate a maze of complex testing, certifications, and inspection procedures before it is authorized for unsupervised operation. Every single detail from the load-bearing chassis and battery system to the flight control software must pass hundreds of simulation tests, crash tests, and extreme weather condition trials to prove absolute safety in three-dimensional space. Because even a slight structural deviation or a software miscalculation in the air might never offer a chance for correction. And precisely because of this, Tesla is not taking the old route. Instead of using exposed propellers like most current eVTOL models, the company is reportedly developing an electric jet engine, a technology inspired by SpaceX's propulsion system, but scaled down and refined for civilian vehicles. Unlike the roar of traditional jet engines, this type of motor is quieter, cleaner, and more efficient, providing a smooth flying sensation that is almost like gliding through the air. Not only does it significantly reduce noise to about 65 dB, equivalent to a normal conversation, but it also completely eliminates carbon emissions. Doesn't that sound mesmerizing? A car that can soar into the sky, cutting hours-long journeys down to mere minutes, expanding the travel radius and drastically reducing transportation costs to an almost unbelievable degree. Yet accompanying that excitement is a legitimate concern. Controlling a flying vehicle isn't the same as driving on the road. It demands absolute precision, split-second reactions, and absolute faith in the technology. A minor glitch in the control system or a sensor could result in unpredictable consequences. The reality is that the survival rate in aviation accidents is consistently much lower than in traffic accidents. And that is the single biggest challenge Tesla must overcome: how to combine the experience of free flight with absolute safety. However, beneath it all, the Tesla flying car is not merely an engineering project. It is Elon Musk's global competitive statement, an assertion that the West can still take the lead in the era of personal flight technology before China can catch up. However, to realize that dream, there is another major hurdle: regulations. Currently, the world has virtually no clear set of laws for personal flying vehicles. That means Tesla will have to collaborate closely with aviation and transportation authorities to collectively build entirely new standards, from air traffic management and operational licensing to urban takeoff and landing infrastructure. But if there is one company influential enough to rewrite the rule book for the entire transportation industry, it is surely Tesla. Do you think flying cars will replace traditional vehicles by 2030? What feature would make you feel truly safe flying in a Tesla? Thanks for watching. If you enjoyed this deep dive into Tesla's bold vision for the future, don't forget to like, subscribe, and turn on notifications so you never miss what comes next. What do you think about the Tesla flying car? Revolutionary leap or risky dream? Share your thoughts below. And as always, we'll see you in the next video.